Thank you very much for this warm welcome. And also a welcome from my side to the audience here and to all the listeners on the internet. So today we'll speak about dev containers. And I want that you get 2 points from my talk today. So first of all, I want to show you the basic concepts of dev containers. It's the sense that you know what's behind this tool and how does it work. And the second point is that, to my personal point of view, I think that dev containers are, at the moment, one of the best methods to get a consistent Python development environment. And why does a consistent Python development environment really matters? So I think consistency is the key for reproduction. And I've just made a picture of a car manufacturer, and there's an assembly line where the cars are rolling out. And what do you expect from cars? You expect from cars that they work at the end of the assembly line, that they work as expected. Then when you go in, you open the door, you start the motor, and you can drive. Now, think yourself, how many times did you fail to reproduce a Python development environment? Because we're quite often reproducing Python development environments. So we're reproducing them, for example, when we come back to our project, we skipped it for 3 months, we come back, so we need to reproduce our environment as we got 3 months earlier. We have to reproduce it when we want to deploy our code for production, that it's running on the servers in the same way as it's running on our local laptop. Or, from my point of view, the most important part is when we want to share code with our colleagues or the community. And I've just been in a talk also today of Artem, and he also just pointed out that reproduction is really critical for Python code. So just think about reproduction, that it really matters to the Python community, I think, at some point. And let's see what's the problem and what's the road to reproduction. And therefore, I've just chosen an example. So, for example, in Fast API web server, you want to write down a Fast API web server. Who knows Fast API? First survey. Ah, great. Those who don't know Fast API, just think of a simple Flask server, and I think then we got 99% coverage here inside this room. So, when you want to make a Fast API web server, you go to the Fast API website and go to the docs and copy the example code. That's exactly the example code. And you read further the documentation and see, okay, when I want to start a web server, I go to the console, I do a pip install. You have to install Fast API and Unicon, 2 packages. And the docs say that afterwards I should start it with the command Unicon main app. That's it. Everything's working. Well, maybe. If it's your very first Python project, yes, for sure, this will work. If it's your second or third one, you most probably get to a point where when you install the packages, you get feedback, oh, I can't install the package. It's just a discrepancy of dependency of another package. And then you read, okay, then I have to do a virtual env. Okay, you start doing virtual env, you're doing the next 10, 12 projects with virtual envs. But you come to a point where a package says, no, I don't want to run, because you got the wrong Python version. I need Python 3.11, not 3.8. Okay, then you install the next Python interpreter. And finally, it's the year 2024, and you're a data scientist or a machine learning expert, and yeah, you want to get access to hardware acceleration. And you install some, well, TensorFlow, system libraries, and so on. And well, over the months of working, your system descends into chaos, as Randall Munro drawn here on the, well, on the screen. And I love this picture because he really got the points where Python and one Python development environment descend into chaos and what we need to care about if we want to have a consistent Python development environment. So let's analyze this picture. So there's the first level which we have to think about when we want consistent Python development environments, the Python packages. We have to fix the Python versions, the Python package version we are installing. So when we go back to our example, we installed Fast API, but if we really want to reproduce the result, we have to keep care about the version. For example, Fast API 0.110.1. They're really at 110. I wonder why when they reach number 1. But I've chosen the color green because in the Python ecosystem, we got pretty good solutions for this problem to fix a package version and, well, even the building wheel. So I just think about poetry, which I love to use, but there are plenty of other good solutions out there. So, okay. The second level is the interpreter level. This is a bit trickier. We don't have so much option to switch our Python environment, interpreter in our Python environment. I'm just thinking about Condor or PyEnv, yes. So we got solutions, but we don't have as many in our ecosystem. So, but then the third level comes, the system level. That's what I mentioned earlier when you become a machine learning expert or data scientist and you want to use hardware acceleration. And at that point, you have to install some C or C++ libraries, for example, on a system level. And there, to my knowledge, we don't have really good solutions on our Python ecosystem. So, what may be a solution? There's one golden rule in informatics. Just look around what problems others had. Perhaps there were the same problems anywhere, and copy the solution to it. And 5 years ago, when I started working at a company, I got a lot of colleagues from the Java and Kotlin space. They're doing deploying databases, front and back end services. And I got in touch with containers. And I learned to love containers. So now comes a very critical point in this talk, and I make a survey. Who knows about containers? Please raise up your hands. Ah, that's pretty much. Who doesn't know? Counter test? 2 persons, 3 persons? Okay, I don't want to lose you. So let's recapitulate. Containers are beautiful because they solve some problems. Yeah, I want to convince you. So I grew up in the 90s using computers, and when I had to install a web server, everything was fine. But when you installed a database next to the web server, you have to keep sure that the system libraries were compatible. And all those administrators out there had the same problems, and they want to get rid of these problems. So they just thought about somehow isolation techniques. So you have a common operating system, for example Linux, you get a kernel, and you put just other operating systems on top sharing the same kernel. And one quite known solution for this nowadays is Docker. So you install Docker on your laptop and you get access to this container technology. And in fact, you can use containers such that your Python environment lives in splendid isolation. And we'll just look how this works by, going back to our web server example. So how do I deploy a web server, for example, Fast API web server using Docker in order to derive a method how I can get into development with this container? So let's come back. When you want to Dockerize your Fast API web server, you go on to the console back again and you do a pip freeze and save the output into a requirements.txt file. This is the simplest method to, to somehow fix the package version. You can argue if it's the best one. I wouldn't say it because I'm using Poetry. I would say use Positry. Someone else would use something else. So there are a lot of solutions there for fixing it, but it's the shortest one to get on a single slide, such that everybody can read it. So, and afterwards, we are now going into the Docker world. So we set up a Docker file, and for those of you who don't use Docker, I'm a mathematician, and you get some definitions of how this thing works. So a container is created by an image, and an image is defined by a Docker file. And you build from the Docker file the image, and then start the container back. So this you have to keep care about. So, and let's see how we containerize it. So in our Docker file, in the very first line, we take an image for, well, let's say a repository from Docker Hub, and we take the Python 3.11 bullseye image. And in doing so, we fixed already two things: the system and the interpreter. We've chosen a Debian bullseye system, which is more or less fixed now, and we've chosen the Python interpreter 3.11. Great. Then we have to take care about our project, so we copy all our files from our working directory to our image later when it's built. And we run in build time a pip install to fix the packages in our container. And then we just say, oh, okay, when you'll ever be started as a container, do the command uvcon main app in order to start the web server. And now you go back to your console, you make docker build, you say, okay, I build now this image and name it my image, and the context is the dot. So keep care about everything which is lying in my working directory. And afterwards, so what will you see when you really type it in your console? It will download the Docker image, and it will copy all files inside. It will do the pip installs. You see how the package is getting installed, and that's it. It's got saved on your local machine, and you do a docker run my image, and you'll see now that the command is executing, the web server is running isolated on your machine. Woo! So we containerized our web server. But that's not the thing we wanted to do. We wanted to do development, really. Yeah? That's our goal. And you could actually go inside the container using your favorite IDE Vim. I hope it is or not. Okay. And start programming. And you would have everything inside the container you need to program using Vim. Okay. But that's not the way how you like it. You would rather think about, okay, I want somehow a sync between my directory in the host system and some directory, let's call it workspace, inside my container. And you can do this with Docker. So we'll go back to our console. We even leave this Docker file because we now want something more interactive. So we say docker run, and now comes do or open an interactive session with my container. So open a bash for me, please. And we say, okay, as a basis, we use again this Python 3.11 bullseye image. And in addition to this, we want our sync. So please mount my local directory, here the dot, of my workspace, of my project, into this workspace folder, and make the sync. So on the next slide, on the next command line, after doing so, you get a bash inside your container, and now you install yourself the packages and start the server. But now, congratulations, whoop, no, they're not in sync. Now they're in sync. Now, congratulations, you get your first dev container, or at least containerized development environment. Because you can now work from inside or even from outside. You get access to a fixed Python environment. And there's not much missing to transfer this solution into a dev container specified solution. And that's one key point I want that you take away from this talk, that when we talk about dev container, it's basically 90% Docker, or something another container solution in future perhaps, and only a 10% service layer, which gives us some benefits in terms of convenience in using it. So let's see how we transfer this solution in a dev container context. If you want to use now dev containers, you create a dev container JSON inside your project. And you need now 3 lines in your JSON. First of all, you give the baby a name. So it's, for example, the PyCon dev container. Then you say to him, okay, I use this Python 3.11 bullseye image as before in the Docker run. And as we did afterwards, after upstarting the container, as we did the installation of the requirements file, so we're doing pip install -r requirements. That's the dev container JSON. And you don't see the thing with the mounting inside the specification, because the dev container standard will do it for us. So when your IDE supports dev containers, it's keeping care about the thing. And that's the service layer I mentioned, 10%, which are on top. And who thinks that dev containers are really limited to VS Code or something like this? Hands up. Ah, okay, a few. Okay, so I have to admit, the dev container specification came up in the context of GitHub and Microsoft, but it's growing. So more and more IDEs are supporting it, or cloud providers are offering that you can spin off a development environment using dev containers. And I know my colleagues, for example, and you're using a lot of PyCharm. Nowadays, PyCharm is supporting dev containers. You can use Anvem, for example. It supports also dev containers. So it's getting quite common. And the dev container specification is indeed open source, so, and got 2,783 GitHub stars, and perhaps get even more stars after this talk. So, and the beautiful thing is, when you get such a dev container JSON inside your repository, you are really just one click away from a working Python development environment. So when I clone a repository with a dev container JSON inside, my, for example, VS Code IDE says, oh, I found a dev container JSON. Shall I open the container for you? And say, yes, do it, please, because I don't want to read the documentation, how to get a Python development environment. And that's the second thing, which is really important to know, I think, about dev containers. So when you start using dev containers for your projects in the community or at your company, it's some sort of living documentation. Because you know, when at least one developer is working with a dev container JSON, you have one place you can go to read how the project is started, even if you're not using dev containers at all. And that's really one big benefit compared to documentation, which can have just discrepancy. So please, when you use dev containers, put it also to your repository. Make a git add. It's not just for development, it's also for documentation in my point of view. So, and we can now even do more things with this dev container JSON. So, for example, we got a fast API web server. So web servers have always API keys. We can, for example, say, okay, the API key for our web server is stored in a .env file, and we pass it to the container, defining that there are additional arguments for the container at startup, which are shown here. So //env file, and oh, there's missing a dot. Or is it? Yeah, no, there is one. I just don't see it from here. And that's it. So, and you get now basically access to all features of Docker which is below. It would be the same arguments you would put behind the Docker run command in a convenient manner, in the sense of that you don't have to take care about mounting your working directory inside. And for sure, we have to mention one thing. When you use dev containers alone, it doesn't solve your problems. It just solves your problems when you think about fixing your packages and your interpreters, as you did before when you did it in a reproducible way. But in addition to this, with dev containers, you can keep care about what's installed on a system level and reproduce it. I think that's the reason why you should use dev containers. It's really great for reproduction and documentation, as we said. And I've just joined some talks on Monday about security. I think dev containers are really also an option when you think about untrusted packages. So let me describe the problem for you. So when you install a package from PyPy, I've learned on Monday that it's not so well protected in the sense of, are there any vulnerabilities or backdoors inside, or is it really secure to run the package? And I read some news that PyPy is really problems assuring it, so they stopped new projects, for example, which are allowed to PyPy for some days, to care about security issues. And you should really think about using dev containers when you have sensitive information on your laptop, because Docker or any other container technique gives you another level of security on your system. So, for example, Docker is using C groups and namespaces on kernel level, and you get a certain possibilities to isolate the code running inside a container from your host system. So when you install really a package with vulnerabilities, which gets exploited, at least the attacker doesn't have access to your local file system directly. He may have access to this mounted directory on somehow, but he doesn't have access to your complete file system where also your SSH keys, your private keys are stored. So I really love this, this extra level of security. And speaking about security, perhaps also a reminder, when you're using, well, anything you don't trust, perhaps you shouldn't use your SSH key to download it from GitHub, GitLab, etc. Perhaps you should use tokens, but that's a completely different story. So, and the thing dev containers are really great in is remote computing. And that's why I use them most of the time. And they are good in remote computing because that's the origin, I think, of dev containers, so far as I know. So when you go on GitHub, you see perhaps the button, please make me a code space. And this code space is, in fact, a dev container living in the GitHub cloud. So I think dev containers are really an option for the Python community when they want to get more members from the community to contribute to code. Because, well, okay, there's some issue with GitHub if really a lot of community projects should be on GitHub, but there are other options. And the thing is, when you get a dev container JSON inside your repository, when there's a new one coming in, he can just spawn a development environment inside the cloud and start programming, and he doesn't have an overhead in the sense of setting up an development environment, setting up unit tests himself. When he just wants to do a little contribution, a small pull request, I think this is really something which is attractive to get more community members working on a code. And yeah, and remote computing, not really in the cloud, but on a bare metal server with dedicated GPUs, was was my point where I got in touch with dev containers. And till the end of last year, there was really not so much documentation on how to do it. And that's why I added this to the abstract of the talk. So we'll now pass to the remote computing features of dev containers, especially if you want to use GPUs. I don't know for how many of you is this interesting, just to get feedback. Okay, so we're using GPUs. One question I got is, do you use these GPUs on a bare metal server or on a virtual environment? So do you go to Paperspace or somebody else and run up a virtual machine with GPUs? Who does this? Okay, and who has a bare metal server? Okay, we are not so GPU pure as we mean. So let's dive into this one. So, a lot of you raised your hand having a bare metal server. And when you get a bare metal server, which is not your laptop, because an A100 has not so much place inside this laptop, it's somewhere else. And you have to connect your laptop to this somewhere else. And when it's a bare metal server, it's an SSH connection most probably. If you're using, well, as I told, GitHub Codespace, for example, you just open it in a browser. But we are now really looking on this SSH thing, because that's the thing I'm using, and what I think you're using too. So, the thing is, when you want to start using dev container with your GPU remote machine, you first have to think about some abstraction layer between you and the dev container. And as I say, GPU, the most probably GPU thing you got hardware is an NVIDIA card. So you have to take sure, or be sure that on your remote machine, you got two things installed. So first of all, Docker, because it's the basis of all, and the Docker Container Toolkit, NVIDIA Docker Toolkit. I don't know, they're changing their names. So and when you get these two things installed on the remote system, it's just like coding on your own machine. You can just forget about the rest. And that's really very cool. And that's the idea of this isolation. So dev containers have really one pro. So you don't need to care about the operating system, which gives you access to this kernel. You just put your Docker container on the machine for development. So, and now let's see how we can get access to the GPUs using dev containers. Now, we'll write again a Docker file, because it's only 2 months ago, I think, that Microsoft has really posted templates for using GPUs on GitHub. So as I wrote this, I had to do it on my own. And as I did it on my own, I wrote this Docker file, and I know from my time before dev containers that I should use an NVIDIA CUDA image, which NVIDIA prepared for us in order to get access to this CUDA using the container toolkit. And that's really a point you have to be, well, careful, because I mentioned the container toolkit. And you have to be sure that the container toolkit is compatible with your CUDA version. So the first point. And there are other points which I'll mention, which makes it a bit tricky why there are not generic solutions for this. But you get somehow a recipe how you can solve it yourself. And if you can't solve it, just message me. So, NVIDIA did some work for us. So they took an Ubuntu system, Ubuntu 22.04, and installed CUDA on it. So what's missing now is, when we think back, so we fixed now the system. This is always the red marks I used before. So we now have to fix the interpreter. And there I'm just don't care about. I just use the interpreter which is given by Ubuntu. And there will be a talk, I'll refer to it later or perhaps now. Ask Jürgen Mach tomorrow why Ubuntu is providing the version it provides. He will answer it. I asked him. I met him before. So, we are now just happy to use the interpreter Ubuntu provides us in the version 22.04. And we now come back to the dev container JSON. So before we have seen that we've used an image. But now, as we did some individual stuff, we just use the build command in the dev container specification. So we can even use our Docker file to build a dev container. And here, we specified Docker file in our project level and give him also the context, which we've seen earlier. This was also the dot after the command. And afterwards, again, the post create command, pip install -r requirement. And now we come back to the run args, which we've seen before, passing the environment variables. Now we're using this run args to pass the information that when the Docker container runs up, it should have access to all GPUs on my bare metal server, because the other colleagues shouldn't be working with it. I want it all. Yeah, that's something really you have to take up care about. When you get a bare metal server and you get colleagues, you have to just speak with them who is using these GPUs. So it's tricky, but giving a coffee or two, you can convince your colleague doing the computations tomorrow, I think. So, in addition to this, such that you don't get warnings from PyTorch, for example, you have to augment the SHM size of your container to, well, perhaps 1 gigabyte, perhaps 2 gigabyte. You have just to try. So when there are warnings, increment the size. Yeah, sorry, that's how I'm doing it. So, everything's fine? Almost, because I've skipped something, and something really important. So when I first did it last year, I just thought, oh my God, I just tested PyTorch. Does it have access to my GPUs? And it said, no, I don't have access. I was asked why. And when you install PyTorch packages, you have to keep care about one thing. You have to keep care about that you're using a certain building wheel, which is somehow compatible with your CUDA library. So here it's the CUDA 11.8 library, which is of course compatible with the CUDA 11.7 on top here installed. Don't laugh, I've fixed CUDA for more than 3 years, and at least when there are version switches, for example, when they switch from 11.6 to 11.7, you have to just keep care about which libraries are compatible. You have to test it. That's sometimes undocumented, but they're really going to be better, I have really to say. Yes. So, what's REST? Have you ever used dev containers before in your everyday life as programmer? Who did it? Hands up. Okay. Who will give it a try now? Very good. Because I think I wouldn't use dev container if there weren't those colleagues using containers in a completely different domain. And I think that's why this talk is important. I just want to transfer this domain knowledge to the Python community, that there exists something which can help us solving problems. And I hope that you're really interested in trying. So I've just put on GitHub a repository. You can start working with it. I also post a lot of information, or no, okay, not a lot of, some information, but you can start reading further. And feel free to connect or ask questions now or even later. And I don't have anything to say anymore. Oh, I forgot something. Yeah, because I love to be at PyCon. And I think we should now applaud to all the volunteers and professionals which are doing a great job over the last day and which will do a great job, I'm sure, for the next day, that this conference is such a lovely place that you always want to come back. So, applause to the volunteers and the professionals.
Thank you very much, Thomas. And it was a very nice presentation. I expected, as a mathematician who went through a lot of different passes now in the cybersecurity. So it was quite interesting, and we have a lot of questions.
Very good. We get a lot of time for the questions.
First is, how do you set up debugging with dev containers?
Okay. So setting up debugging with dev containers, I think, depends on your IDE. So I got very good experience with VS Code, which is, as you could expect, because they got the idea of using dev containers. So if you use VS Code, you can straightforward debug. You even don't know about the difference. It's just a small bar on the down left side which says, oh, you're now in a dev container living. So there you can just go straight forward. I don't have as much experience in other IDEs, but at least when you're using Anvil, they're using the VS Code extensions very much, so you should get through there, and I'm for sure that PyCharm has this debugging feature out of the box now as they're stable. They were in beta phase till last month, I think. And I got just feedback from my colleagues. They got problems, but they should have been fixed in the last month because they are now not anymore complaining about dev containers.
Thanks. We have a related question to the IDEs. Is there any, how to best ensure cross-IDE compatibilities between, let's say, VS and also JetBrains and so on? Okay,
so the support of dev containers is getting better and better. But for sure, if you want the most convenient experience of dev container, at the moment VS Code is offering the best experience. But the others will also do it, because why I'm so convinced about dev containers. You've seen really to the mid of this talk that I've only used Docker to reproduce something which is very near to a dev container. And it's really that dev containers is 90% Docker and 10% a service layer which gives convenience. And I think this is somehow something which makes a tool great, when it doesn't reinvent the wheel, but puts something on top of an existing solution which is running and stable and used in everyday life.
Thanks. Every developer typically has a slightly different dev container JSON file. Yes. So how do you handle this when adding this to the repository?
Okay, so everyone has its own, customizations. That's it, how we would call it. So I would really push, or that's how I do it, a minimal dev container JSON to the repository, which gives you access somehow to that the development environment is reproducible. And the thing is, when you get customization, I just store them along in another file, which is perhaps my customization, and you can add this, for example, to git ignore, just not to be sure that it won't be added on git push, and you can just switch it. So yes, it's a problem that you cannot expect any other developer using your dev container JSON, especially when there are customization inside about VS Code, what extension you should install. But if I'm new to a project, I would love to have at least one dev container JSON which is working, and I would just customize it myself and store it alongside where it's not getting pushed.
Great. So since we have still some time, I try to ask more questions. Would you recommend using dev containers together with the Docker Compose? And if so,
yes, and that's really great. This question is great because Docker Compose works out of the box with dev containers. So we've seen a really simple setup with fast API web server, but you can write a Docker Compose JSON, a dev container JSON on top of your Docker Compose solution, where you also start up a database and a front end such that a new developer coming into the project sees also how the changes are affected on the front end he's doing in the back end, or that he gets a database for integration tests, for example. So Docker Compose and dev container is perfect compatible, and there is existing really good documentation for this.
Thanks. And how to run tests on the dev containers when they also require, for example, some databases?
Yes, okay. I think this one is really near connected to the setup with Docker Compose. So when you have unit tests which need a database, you can start up a database next to your dev, or next to your dev container, inside your dev container. It will be two containers interconnected. But that's really a possibility how to start up a database next to your development container, and you get access to it, and you can run your units. This is a perfect setting. And I just wanted to say one more thing, but I don't remember it. What was the question? Was there another, a second part, no? I think there was something.
It was just if possibly it requires databases, or?
No, perhaps I remind later.
There is one more question, which I assume that you mentioned this in the talk. It says that I'm using dev containers, but others in the group not.
Yes.
So how to collaborate? So what's your best, let's say?
Ignore them. No, I mean, I don't want others to use the tools I think which are working fine for me, because that's not the way how it should work. So I think the way it should work is you're using dev containers, so the other colleagues should respect that you're pushing it. For some colleagues which might join the project and also convince the dev container are useful to them. But I'm not a fan of telling others only use dev containers. Because the dev container JSON, as I said before, has its right to exist next to the usage as development container itself, but also documentation to somehow documentate what is a working setup for this project.
Related to this question, how about using stuff like poetry, hatch, and so on in the containers?
Yes. So on this dev container 101 repository, I refer to two other projects which are using poetry to fix the packages. So when you decided to use poetry, you will add, of course, a poetry toml, a PyProject toml, and a poetry log file to your dev container. And afterwards, it's poetry install in your post create command. And perhaps this is, when we come to this post create command, we have to mention one thing. Who knows the project Ludwig, Uber Ludwig, and machine learning? Okay. Who knows Ray? Ray GPU? Okay, more. When you think that it's a good idea to use the Ray image to get GPU support. So when you not want to use this NVIDIA CUDA file I showed you before here, but you think that you can take the Ray thing to get a basis. But there's one thing you really have to keep care. So it's about the mounting of the directory. So there's some magic going on behind the scenes in order to get a convenient matching of the workspace folder to your My Project folder. So you define, for example, that you're on the remote system, the user, my user, and on your local system, you're somebody else. Joey, John Doe, or Jane Doe, to be, no? And the magic is when the dev container is spun off, they're doing a matching of permissions and UIDs, who owns the file, etc., etc. And the Ray image got one thing. They installed before Python packages on the user folder. And all these Python packages, when you know Python packages with GPU support can have 6 gigs. And they're just doing a chmod. And this takes half an hour to spin off. So, and that's why when you're really installing the GPU packages with CUDA inside, do it as post-create command, otherwise you will wait a half an hour for your dev container to spin off. This is one thing you should keep care of. So please, when you install packages in a dev containers, I recommend you to use the post-create command.
Thank you, Thomas. We're out of time now, but there are a lot of more questions. Thomas probably will be around here, so maybe you can approach
Drink a coffee with me.
Thank you for being here, and enjoy your coffee break.